Hi, this is James with Northern Arizona Wind and Sun.
And this is Logan.
Today we're going to talk about how to use our solar load calculator. Down here in the bottom right hand corner is a link directly to our solar load calculator.
So once you navigate to the off-grid solar load calculator page, you'll see a link at the top of the page there, and that will take you to another page with more information about how to use the load calculator and why we need this information to help you design a system. So one big misconception we get quite a bit is the difference between power and energy. So they sound like they would be interchangeable, but they're actually quite different. Power is typically measured in watts. Energy would be measured in watt hours, or more commonly kilowatt hours. With Ohm's law, we can essentially figure out the amount of power a device or an appliance consumes based on the ratings that are usually posted on that specific device.
For example, if you have a 100-watt light bulb, it's operating at 120 volts AC, it's 100 watts, so theoretically it would draw about 8 amps, something like that. So Ohm's law, that interaction between the amount of power and the voltage something operates at, also will provide you with the current. You can calculate this in reverse as well. So if you know the voltage something operates on and how much current it draws, you can therefore calculate how many watts it will consume.
So another way to think about the difference between power and energy is power is the instantaneous amount of wattage or power that you're using, that a device is consuming in an instant. Energy is that power over time. A kilowatt hour is a common unit used to measure energy, and that would be just like you would receive a bill from your electric company. They would bill you for the amount of energy you're using in kilowatt hours, not in watts.
Which is essentially 1,000 watt hours, or in the case of a 100-watt light bulb, if that was running for 10 hours, it would be essentially 1 kilowatt hour of energy consumption. So now we'll go to the actual load evaluation page and start showing you how to put in some loads and how to put in some custom loads.
So we're back at our load calculator homepage here, and at the top of the page there you can see some blank fields asking for the appliance, the quantity, how much power, watts it consumes, and then your daily runtime and days per week. So there's a couple different ways this can be done. If you're just starting out or trying to get a rough idea and maybe you don't have your appliances purchased for your house already, maybe it's a new building being built, we do have quite a few common household appliances and loads listed on this page with an estimated wattage or power consumption value. So if you're really just trying to get in the ballpark to get started, you can use the values that are posted on this page to get you an idea. It's as simple as just clicking the plus sign next to an individual load.
Let's use a coffee maker, for example.
All right, and so you can just hit the plus sign next to the individual appliance, and then that will import it up to the top row. It'll have the same wattage value posted that's on the bottom there, and it'll default to quantity 1 in 1 hour per day. So if you have 2 coffee pots, or maybe you make coffee multiple times per day and you want to change your runtime from 1 hour to 2, it's as simple as just editing that text box.
Or if you're wise in an off-grid application and you turn your coffee pot off after you make a cup of coffee, then you could probably just put it in for like 15 minutes rather than one whole hour.
Exactly. And then you can see how the estimated energy total changes according to the runtime that you're entering up top there.
So now let's just go and throw in a bunch of items that are commonly used in a regular home and start to see what that adds up to be. The other thing that's kind of important here is you can custom input a value, right? So let's just say you had a water pump that was 1,500 watts and it ran for 2 hours a day, 7 days a week. You can custom input a value. To add more, you'll simply just add more appliances. Okay. These are just generalized values on, these default units. If you want to get a more precise unit value, look on the actual appliance you're going to use. A great indication is, for example, if you go to your favorite hardware store or whatever to get a refrigerator, a lot of those will have a yellow tag on them that specifies how many kilowatt hours a year the average homeowner will see as far as consumption for that particular product. If you divide that by 364 or 5 days in a year, essentially it'll give you a daily kilowatt hour value, and then you can just divide that by 24 or whatever makes sense to figure out how many watt hours that particular product is going to use. Or you can simply just add that to your end valuation to find out what certain appliances with a duty cycle, for example, refrigerators, furnaces, air conditioners, they have a duty cycle, and so assuming they operate 24 hours a day is not realistic. A refrigerator draw maybe 150, 250, 300 watts depending on how large the refrigerator is, but it only really does it for 15 or 20 minutes for every hour. So that's really difficult to input into a load evaluation unless you actually know the duty cycle. So looking back at the appliance and seeing how it's rated, if it's an Energy Star rated appliance, go to Energy Star's website and look up the appliance, and it'll actually tell you what they expect in kilowatt hours a year from that device, and you can actually figure out specifically what daily consumption that product is going to use. So let's add a bunch of stuff.
Sure.
All right. What do you think?
Let's go ahead and add a...
Let's get rid of the water pump for now.
Should we do a refrigerator?
Yeah, of course. This is a perfect example right here, though. So this refrigerator value has been adjusted to a 24-hour period of time because it has a duty cycle. Your average, your average refrigerator usually draws about a 1.5 kilowatt hours a day, or 1,500 watt hours a day. So now that'll vary significantly. If you get like a brand new Samsung or whatever LG refrigerator that's like just come off the market with inverter-based technology inside it, those things are extremely energy efficient, and you might cut that value in half. So to do a quick summary of what you're going to consume, using these values is great. But if you really want to nail it down, start looking at the actual appliances you're going to use.
Exactly.
Yeah.
Exactly.
All right. What other things?
Maybe let's do a couple ceiling fans.
So you can add one single ceiling fan, or you can do two ceiling fans like this, or you can change the value of how many ceiling fans you have. If you keep one on high and one on low, you could put in two separate values. So we could have one fan running on max power for, let's just say 5 hours a day, and then we can have another fan running at low power for 24 hours a day. And a lot of ceiling fans, for example, are rated based on their power as well. Mm-hmm. So you can look them up. What else?
Let's see, maybe a TV.
Okay. Anybody off grid's probably gonna use that LED, right?
That's a pretty common appliance.
Yeah. But most people don't watch TV for an hour. Let's just say 3 hours. Okay. What else? Computer, toaster oven, laptop.
Everybody's got a laptop, yeah.
All right. Those typically charge for 3 or 4 hours. Say 3 hours. Hair dryer.
That sounds good.
It's a pretty common one. So very rarely does someone use a hair dryer for an hour. Usually it's maybe 15 minutes. See, all these values default to 1 hour. So you got to consider the loads. So we'll drop that down to 15 minutes. There's a bunch of LED lights. Let's throw let's throw like, I don't know, 6, 8 lights in there, and they all might run in varying amounts, but let's
Maybe
just say
couple
3 hours in
yeah.
total. It's a safe assumption. You want to talk about air conditioners?
Sure.
Air conditioners are tough. They're a tough topic. So again, these kind of loads are duty cycle related. So it's, unless you really know the characteristics of your air conditioner, you're really not going to know how much that duty cycle is. And the other thing that's going to be fairly location based is going to be like that duty cycle is going to be dictated based on the location.
Oh, absolutely. Yeah. Based on how hot it gets where you live and how often you think you need to use the air conditioner. For us here in Flagstaff, Arizona, we do have some pretty mild summers, so most houses in this area do not have an air conditioner. We do get some inquiries of people wanting to include that in their energy profile. And you can see when we added this air conditioner, granted a 12-hour runtime per day is maybe a little bit much, but we can see how significantly the energy consumption shot up.
Right, so before the air conditioner, we were at 5 kilowatt hours a day. It illustrated as 5,000 watt hours, right? As soon as we add the air conditioner, jumped up to 47 kilowatt hours a day. So now, is that a realistic value? It's impossible to know until you actually kind of get this in there. So it's definitely an estimate, but there's a significant amount of energy that an air conditioner uses. Now, this particular air conditioner is your standard, like, I think a 2 to 3 ton unit, something like that. We find that a lot of people in off-grid applications tend to use like mini splits or inverter-based like heat pumps, and the amount of energy that they use for a similar like conversion is usually a lot less. So take a look at the actual appliance. This is one of those cases where you definitely want to take a look at the appliance that you're going to be using.
Definitely.
And don't just use an estimated value. Like, find out what air conditioner you're going to be using and input that information, and specifically the model as well, into this line here. Because at the end of this, we'll show you, but this is going to be sent to us and you. So if you send it to us, then we can get in touch with you, figure out what you're doing. So if we kind of know what appliance it is and how well you did the evaluation, we'll have a lot less questions, and we'll just be able to start putting something together for you. So let's add a few more things, and then we'll talk about the results. So let's see. Most houses have a few smoke detectors. Let's see. We'll do a dishwasher. We'll do a clothes washer. Where's the hot water heater?
Right there. Yeah, that's a big one too.
Yeah, that's another one of those ones. Okay, so now we have several things in here. I added a few items. Let's adjust them. So what do you think? I mean, most houses will have like 5.
Yeah, I'd say a handful, and those are continuous. Yeah.
A dishwasher, so this is defaults to an hour a day. If you're like my family, the dishwasher goes every day, but that's not always the case. So over here, so far, pretty much all the loads we did were daily loads. But with the dishwasher, maybe you do it 4 times a week or something like that. Whatever is realistic. So you can change that value. The daily value over here on the right hand side isn't going to change, because ultimately that's going to calculate the daily energy consumption. But your average or weekly energy consumption is going to vary. So it helps us to kind of see how much variance is going to be in your load evaluation. They tend to be fairly similar,
Right.
and we know that's what we can stick with.
Exactly. Yeah.
Right. So, clothes washer's kind of the same way. Let's just say you use it 4 times a week for an hour wash. You could use a gas dryer, for example, if I can find it. There you go. So gas dryer would probably be the same 4 times a week, 1 hour. Now an electric water heater, this is another one of those duty cycle loads.
Yeah.
You know?
Yeah.
So
this one on the load evaluation is electric. You can see at 5,000 watts, that's a pretty hefty load in terms of power. A lot of people, especially if you're off-grid, I'd say most people are using natural gas or propane to heat their water up, but in this case we have an electric model on there. But that is another device that does have somewhat of a duty cycle, so even though you may have hot water 24/7, that doesn't necessarily always mean the elements inside the hot water heater are active all day long. So that's another instance where if you do have specific information about the water heater you're using, any details on its power consumption or energy consumption, you'd want to put those specific details in. Again, this is kind of just to give us a rough estimate.
it's usually safe to say that a water heater is going to run fairly similar to the duration of time that you use water.
Right.
So
Right.
if you put on, for example, a well pump, let's just do like a 3rd horsepower well, like booster pump essentially. If you figure, an hour a day for like family showers or whatever, and then maybe an extra hour in there for other like water loads consumption. So
Don't forget the dishwasher.
Yeah, well, yeah, exactly. So like maybe 2 to 3 hours of water runtime, let's just say. Then it's probably safe to say that the water heater's overall consumption is going to reflect that fairly similarly. So 3 to 4 hours on the water heater is a good assumption. Okay, so at this point, let's just say I'm going to do a quarter duty cycle on the air conditioner, which means that it runs for like 6 hours every 24 hours. Like not continuous, with spaces in between, but essentially the duty cycle for the air conditioner is like a quarter of the day. So at this point, we have a total load for the week, or the average and the max values. So you can see they don't vary too much in this particular case because the loads are fairly consistent on a weekly basis. With this, this value is what we would determine the size of the solar array, size of your battery bank. We will also take a look at the loads that you're using as far as power is concerned. With a brief glance, we can take a look at this and say, okay, well, this particular application, being that there's some heavy inductive loads, like the air conditioner, heavy resistive loads, like the electric hot water heater, basically this particular, what would you say this customer would need for an inverter?
I would say you'd want at least an 8,000 watt inverter.
If not,
if not higher.
8 to 12,
Yeah.
maybe 8 to 16. Problem is, if the air conditioner and the hot water heater are running at the same time, you're right at the stretch of your limits for like an 8K.
Right.
From an 8K inverter, so you're probably going to need something more than that. This value here, being that it's 50 kilowatt hours, it'll almost guarantee sink you in a 48 volt battery bank.
Absolutely.
There's really no better way to do that. 8 to 12K, and it really depends on the model of the air conditioner. Again, if you're using like a newer mini split, the like heat pump, essentially you're not going to have a heavy inductive load, and so like this 3,500 watts, that's the continuous rating. But if you're trying to get the compressor and the motors started on that air conditioner, it can surge pretty heavy. So
Yeah.
that's how we would look at that.
Oh yeah.
That's why it's important to know what you're using too, especially with these heavy appliances.
Right. And obviously a big thing, especially for off-gridders, is managing your usage. So if you've already been off-grid, or if you're already energy conscious, I'll say, you're probably aware of what devices you're running and when. So that could not be more critical in an off-grid setting where you're essentially limited to the amount of power that your inverter system can supply. So you're not on the grid with this unlimited source of power that you can run whatever you want, whenever you want. When you're off-grid, you really do need to look a little closer at what kind of power your loads are consuming and what you have on at the same time.
But with that being said, there's loads that you have as a user, as a consumer, you have control over, and then there's loads that you have less control over.
Right.
For example, the hot water heater and the air conditioner, like those are controlled by themselves based on conditions.
Exactly.
Right? And the water pump, like if you're using water, chances are, especially hot water, that hot water heater is going to kick on eventually. And if it's warm, your air conditioner could also kick on. So like those are uncontrollable loads, and those are some of the loads that we'll take a look at when we design something and say, you're not going to be able to regulate these loads continuously. Mm-hmm. And so we need to consider worst case scenario when designing, the actual fundamental power system. So at the bottom down here, there's a little section where you can put in your name, your phone number, your email address, your zip code. Those obviously are fairly important inputs. Some of the desired battery voltage really doesn't matter too much what you put in there, because
not too much.
We're going to, it's going to be dictated to some degree based on your load evaluation. It wouldn't make sense to do this in a 12-volt system. It would be a joke. So, if you put 12 volt in there, we're basically going to just tell you, in order to make this work properly, you're going to need to go 48 volts for this particular project.
Yeah.
As far as comments are concerned, it's really great if you put in, how you plan on mounting the panels, if there's anything to consider when we design something. These are all general questions we're going to ask. What kind of battery preference you have, AGM, flooded lead acid, lithium batteries, what other inputs?
I'd say anything really specific. Maybe if you had sensitive loads, for example, any medical equipment that has to have power 24/7, a CPAP machine, for example, if you need that to run all night, obviously you need enough battery storage to make sure it can stay powered up all night. For the most part, the more information and specifics you can give us about your system or about your application up front, it makes our lives easier. It allows us to get back to you quicker and ultimately get you a complete system design, as fast as we can.
Also, any specific brands. If you've already kind of nailed down, I want to use, a certain brand for the inverter or whatever. If it makes sense, then we'll target that. We just want to, with the comments, if you give us, generally as much information as you can in a concise way, then it makes it so we can actually just get you a quote quickly. We don't have to ask you a bunch of questions and go back and forth. At the very bottom before you send it, there's a little checkbox that says send to NAWS. If you want us to see this and do an evaluation, keep that checked. Otherwise, uncheck it, send it, it'll send it just to yourself. So if you want to send it both to yourself and NAWS, keep it checked, click send, and you're good to go.
That's about it.
And then our team will just start putting it together for you, put together the system, ask you any questions, get in touch with you. We'll get you a bill of materials put together based on your input, or we'll figure out what you need based on your input. we'll put something together for you.
Yep. And we can always make recommendations and answer any questions you might have at really any point in this process. So if you don't know what brand you want to use or batteries or anything really, that's what we're here for.
All right, give us a call, send us an email, get in touch with us any way you want to. We'll be happy to help. Thank you for watching our video. If you enjoyed it, please like, subscribe, and comment.